Good everyone, my name is Graphics. Today we'll be constructing a meshing gear, but this time it will be a pinion and a rack, right? And the question goes like this. It says that a pinion with 20 teeth is to mesh with a rack whose teeth have a pressure angle of 20 degree and addendum of 6 millimeter. The travel of the rack is to be 125 millimeter. Now, what we'll do first of all is to tabulate this parameter into a table, right? And this is what we'll have when we do that. These are the terminologies, right? And the parameters that we should look for before we can even proceed with our drawing. Now, from the main question that is displayed at the top corner here, is telling us that the number of teeth given, it says a pinion with 20 teeth. That means the number of teeth is what? Is 20. So I'm going to input my 20 here for the pinion teeth is 20. So we're talking about what? 20 teeth. Right? Our n is 20. Now, it says the pressure angle in the question is also given to be what? 20 degree. So I'm going to put the 20 degree there. Right? Now, the addendum is given to be 6 from the question. Addendum is what? 6 millimeter. Addendum is 6 millimeter. That is 6 millimeter. Right? Now, one thing you need to know is that the addendum is equal to what? The module. So, if the addendum is 6, the module is also what? Is also 6 millimeter. Right? Now, from this, we should be able to calculate. Now, they give us the distance of the rack to be what? 125 millimeter. So, the rack distance is what? 120 millimeter. That means the rack is spread out. So, we want to calculate the rest of the parameters with the little ones that are written for us, that are given. So, let's start. Since we have the addendum, we have the module and what? The number of teeth. It's easier for you to calculate what? The PCD. So we should know that the PCD, we have the PCD is equals to what? The number of teeth times what? Times the module. The number of teeth times module. I'm using n as my number of teeth and I'm using m as what? My module. Now, if you look at it very well, what is the n? The n here is given to be 20, and what is the module? The module here is given to be what? 6. So it means that my number of teeth, my PCD is equals to what? 120 millimeter. So I'm going to write here the PCD, which is this pitch circle diameter, giving us 120 millimeter. Right? Now, the next we can calculate for here is the addendum, right? So from here, I can easily get that my addendum is equals to what? The addendum plus the clearance, right? Now, from here, our addendum is said to be what? 6 plus the clearance is always given 0.25 multiplied by what? Multiplied by the module. Now, what is our module? Our module is given as what? 6. So if you multiply 0.25 times 6, we are going to be having 1.5. So this will give us what? 6 plus 1.5. Let's go there. 6 plus 1.5. Right? And that will give us what? 7.5 millimeter, right? So I'll go to where the dendum is and I'm going to put 7.5 millimeter. 7.5 millimeter, right? So from here we've gotten this. Now if you look at this, 0.25 times 6 is 1.5, so it means that our clearance is what? 1.5. This is given as 1.5 millimeter. How good does the clearance, not the... Now the next thing we're calculating for here is the BCD, the base circle diameter. Now from what we are doing here, the base circle diameter BCD is giving us the PCD cos the pressure angle, right? Giving us what? The PCD cos the pressure angle. This is symbol chi is giving us what? The symbol for what? The pressure angle. So what is my PCD? My PCD was calculated to be 120 cos, then the chi, the angle is what? 20 degree. So 120 cos 20 will give us, that will give us 112.76 millimeter. So that is my BCD. So I'll come and I'll input my BCD, which is what? 112.76 millimeter. Right? Now the next thing we want to calculate for here is our circular pitch. Now the circular pitch is given as the CP, circular pitch, and that will be equals to what? The pi times what? The module. Now what is the pi? The pi here is giving us 22/7. So we'll say 22 all over 7 multiplied by 6, and that is going to give us 18.85. So we have 18.85. So I'll come here and I'll put 18.85 for my circular pitch. Now the next one will be the circular tooth thickness. Now from here, the circular tooth thickness, I just call it CTT to abbreviate it, will be the circular pitch over 2. And what is circular pitch? 18.85 all over 2, and we are going to be having 9.43 millimeter. That is the circular tooth thickness, the distance of each teeth from each other. Now I'm going to put it here as 9.43, right? So one thing you need to understand here is that whatever dimension you are using here, you're going to apply the same dimension on the rack. Why am I saying that? Because the involute rack has what? It is a spur gear that is rolled flat. So when we have a circle, the mean circumference of the circle is the length of the circle. So it's just like you fold something and you wrap something and you unwrap it. So that is the rack here. So the rack is a spur gear that is rolled out flat, right? So now whatever dimension we have here is the same we'll apply here. Is that okay? So let's start. Now we are given the size of teeth in the question. We say the size of teeth should be 5 size of teeth. So let's start with our drawing and see how we can go about that. Now the next thing we are going to be drawing will be the diagram. We'll need to construct the rack and the gear. So the first thing you first of all do is to draw the length of the rack. So we are given the rack length, or we'll say the rack distance, but we're going to say the travel of the rack, and that is 125 millimeter. So I'm going to place my T-square, my T-square, and I'll draw an horizontal line this way. right? So from that horizontal line, I will try and locate the center. Let's assume that this is the center here. Is that taken? Now, from that center point here, I'll take that point to be my point P. Let me call it, or my point O, and I'm going to draw a vertical line that would come out from there, from this point. So if I do that, I'll be having this. Now, I've gotten the center point here. I can even decide to extend it further, so I'll be needing it. So we're having this way. Now, since the length of the rack is 125, half of it is what? 62.5. So I'm going to measure 62.5 on my meter rule. So if I take my meter rule, I'll place it this way and I'll measure 2.5. So if I start from 0 here and I'll move to this is 60 and 61, 62.5 in between 62 and 63, right? So I'll place it at the center point here and I'll mark left and what and right. That will make my 125. So the length of the rack, I'll say this is A and this is what? This is B. Is that taken? And that is my rack length. Now the next thing I'm going to do is to start constructing the pinion gap first of all. So the PCD, which is the main cylinder that causes the motion in the gear, is given as we have it to be pitch circle diameter, that is 120, right? So I'm going to measure 120 from this point. So in measuring the 120, I'll place it this way. I'll measure the 120. So from half of 120 is what? 60. So I'm taking the half of it, which is 60, because this is the diameter and we need the radius to draw the diameter. So I'll just measure the 60 here, half of it, right? So that point, I'm going to tap that point, that will be the point I'll be taking my measurement from, right? So any measurement I want to take, I'll start from this point here. So what I will just do, I'll now take my compass, place it at this point here, then take it here where at point O, and I'm going to draw my circle this way, as in my arc this way. You can see that. So that is my pitch circle diameter. I'll write it out, the PCD. Now sometimes they might tell you twice full size, right? So you need to multiply this PCD by 2. That again, I will give you twice the full size of it. Now let's proceed. From here, we've done the PCD. The next thing we need to calculate should be the addendum. So the next thing is the addendum, and the addendum is the radial height of the tooth above the PCD. So the height from here above the PCD. So now outside the PCD is the height, then inside the PCD is the what? The depth, right? So if I do that, I'll measure the addendum, which is given as what? 6 millimeter. This is it here, and I'll measure my 6 millimeter. So from here I have the 6 millimeter, starting from this point. This is 0, this is 0.5, and this is 0.6 millimeter. Alright, so I will take my compass, place it at this point here, then take it to this point where I measured just now, and I'm going to draw my arc this way. So that is what? My addendum. That is the addendum, the radial height of the tooth above the PCD. So the next thing we'll do will be the dedendum, which is the radial depth of the tooth below the PCD. We know this is the PCD, right? So below, and we have the dedendum to the what? 7.5. So I'm going to measure the 7.5 from here below. So I'll start from the line AB. So this is 0, this is 5.5, 0.6, 0.7.5 here. what we have here. And I'll take my compass, take it to this point with the reference of this point here. Right? I'm going to draw. So this is what we have here. So that point is my dedendum. Now the next thing we need to do is the base circle. The base circle BCD, we calculated it to be 112.76. So half of 112.76 is going to give us 56.38, right? So I'll measure 56.38, but this time I'm going to measure it from here. I'm not using the full dimension here because of what this diameter. I need half of it to become radius. So I'll start from here and I'll measure 56.38. So I'll take my measurement from here, from this point here. Let me call it point P. So I'll measure, this is 10, from here to here is 50, right? This is 55 and this 56.3. Let me assume is at that point there, right? So I'll place it at this point P, take it to where I just measured, at the point I just picked, and I'm going to get this way. That again. So this is what we have here. That is the PCD at this point here. Are we good? Now we've gotten the PCD, which is what we have here, the BCD. Now the BCD, one thing you need to know, the BCD is always above the dedendum. Is that taken? Now we've done that. Now the next thing we're going to do is to mark at the addendum. I will say let it be what? Point A. And at the base circle, I will say let it be what? Point E. Right? So I need to get 1/3 of what? Of AE. So 1/3 of AE will be my point B. So what I'll do to make it easier, instead of just dividing the line with your line division method, you can take your meter rule and you measure AE. So from AE we have what? That is let me call it 10. From here to this point it says 10. So 10 divided by 3, that will be 3.33. So I'll measure from A 3.33. So if I should move up from A, starting from 0, so this is 0, this is 0.1, 0.2, 0.3, let me say 0.33 somewhere around here. That 0.33 there will be my what? My B. Now draw a line tangential to the base circle from point B. So I'll place it this way. This is my point B and this is the base circle here. So I'll draw a tangential line that will just touch through it from this point here. Over there. From here I'll just draw that tangential. You see that? So where it's meeting the point, let's say is here, and that is what? Point F. Now the next thing I'll do from that point F, I will get 1/4 of points of BF to get D. So I'll measure it from B to F, and that's giving me 24. So 24 divided by 4 will be what? That will give me 6. So I'll measure 6 on F. So if I'm starting from 0, this is my point 0 here. So I'll measure 5 and this 6.6. This is where it is here. So from that point, I'll call it point D. I'll call it point D. So from point D, I'll take my compass and place it at point P here. To point D, you can see it here. To point D, and I'll draw an arc this way. So that's the arc of D. So don't forget that. And just call it the arc of what? The D point there. So we've done that. Now the next stage you do is that from the point D, this point D here, right, I'm going to take it to point B and I'll draw an arc this way. I'll allow here to be faint, and I'll just draw the remaining one. Just need to touch the addendum. All good? That's the first thing you do. Now, where the arc cuts the PCD, you know this is the PCD, if you look at it, this is the PCD here. Where it cuts the PCD, we're going to call it point C. So this point here is what? Point C. Now from that point C, I'll start doing the circular tooth thickness. Circular tooth thickness given as what? 9.43. So I'm going to measure 9.43 on my meter rule. So this is 0. This is 9.43, somewhere around in between 0.9 and 1. Right? So I'll place it at the point C. I'm going to mark along the PCD. So if I mark, so this is first teeth, 2 points makes one teeth. Then I'll go to the next one from here again. I'll mark on it. This, I'll come here also, I'll mark again here. So this is another 2 sets of teeth making one teeth. One tooth, right? Then 1 and 2, then I'll come again. If I mark 1 and again 2, making 3 tooth. I'll come from that point C again. I'll mark towards the left. This is 1, 2, making 4 tooth. From here, this is 1, 2, making 5 tooth, because we're told to draw 5 sides of teeth. Now after you've done that, initially we started from point D here to get this arc here, right? So with the same radius of point DB or BD, you place it at this point, right? And you mark on the D arc. When I say the D arc, I mean this D here. If you trace it, the D arc, you mark it. And this is what we have here. So when you mark it, look at what I'm doing now. Then I'll just switch it gently and place it at this point. So I change it, I'll just come here and I'll mark the next one. You can see that? That's the first teeth. Then I'll come here also at this point, the second point of the tooth thickness. I'll place it here. I'll mark on that line of D, the arc of D. Then I will switch it again like this. Then I'm going to have this. Right? Then I'll place it here also. I'll mark still the arc of D here. Then I'll switch it to this point. And I'll have this. Right? I'll come to the next one too. I'll do the same thing on the tooth thickness here. I'm going to place it here. I'll mark on that arc D. Then I'm going to switch it gently to this point. Then I'll have this. Then I'll come here too. I'll do for here too. I'll mark on the arc of D. I mark it there. I'll switch it to this point. Now get this. Now I've done 3 of it. I'll come here too. I'll do the same thing. I'll mark on the arc of D. Also, I'll switch it to this point with the same radius I'm working with, and I'll get this. I'll come here also. I'll mark on the arc of the D. Then I'll switch it to this point, and I'll have this. I'll come on the point again. I'll mark towards the left. There. I'll switch it to this point, just like I did in my previous video when I was in here. And I have this. I'll come here also. I'll mark towards here on D. Then I'll turn it. And I'll get this. all good. From here I got this, then from the line of D I'll mark here, and I'll switch it. The point of D, then I'll have this. This is what we have here. So I can close the surface off. Let's close them off with a compass and with the radius here. Now close it up. Close it up. I'll close it. Now the next one is to cover up this here, right? I did it in my previous video, but I'll do it here just for those people that are just watching the video for the first time. Or you can just click on this link above here to watch it, but let me just do it here. Now we are looking at this gear here is cutting the addendum here, and it's cutting here also here too, right? So what I'll simply do here is I need the radius of this arc here. So how will I get that? I'm going to get the wire dial. That is, from here I will measure the distance from one beginning of the tooth to the beginning of the corresponding tooth. So from here to here it is 22. Look at it very well. 0 to this point 22, right? So to get the arc now will now be 22 over 7. So it will be 22 over 7. 22 over 7. So if I have the 22 divided by 7, and that give me 3.14. So the arc I'll be using will be what? 3.14, which is approximately 3. So I'm going to measure 3 on my meter rule. I'm going to measure 3 on my meter rule like this. So let's say from 0 here to this point is 3, right? So if I measure the 3, I'll place it at this point where it meets the addendum, and I'm going to mark top like I want to draw a fillet. They call it the fillet. So the fillet is always the wire dial over 7. So I'll just put it here. From here I'll strike an arc. From here also I'll strike another arc. So where they meet, I'll place it at this point, and I'll draw an arc this way. Right? I'll do the same thing for this one too. I'll draw another arc here too. I'll draw another arc here too. So where it meets here, I'll strike here up, strike down, come to this point, I'll cut, come to this point also, I'll cut. So where they meet, I'll also draw another arc this way. So at the end of the day, this is what I'll be having. So that's what I have there, right? So you repeat the same thing you did here for the fillet. Though the fillet is the wider, and the wider is the distance from the beginning of the tooth to the corresponding beginning of the next tooth, right? I will go 22. So the fillet will be what? The wider over 7. So divide by 7, I get the radius of this. So you do that for all the tooths. Now this is what we have here, right? Now the next thing we want to draw now, we want to draw the rack. We are done with the what? The pinion. Now we want to draw what? The rack. So what you do is this. We already know the distance of the rack is from point A to what? To point B. So let's see how we are going to do that. Now, like I said earlier, all the measurements of the pinion is the same width for the rack, especially things like the circular tooth thickness. We know it is 9.43, and we measured it that it is, for instance, from point C to the next tooth. That is the distance, right? So we'll continue marking it on the rack. So if I mark it this way, it is 1 point on the rack. If I come to the next one again, it's another point on the rack. If I come again, another one. If I come again here, another one. If I come again, another one. If I come again, another one here. And also let me continue from here also. I'll mark here. I'll mark here on the straight line. I'll mark here, I'll mark here, I'll mark here, and here. One thing I want you to understand is that what the rack on its own is a spur gear that is rolled out flat. So the rack is a spur gear that is what rolled out flat. Just like when you wrap something, like when you talk about the main length is of the circumference of a circle. The main circumference of a circle is the what? Is the length. That is what called the main length, right? So when you unwrap the spur gear and you make it to be linear, it becomes what? A rack, right? So what a rack simply do is just to convert between rotary motion and what? Linear motion. Now let's see. Now one thing you need to understand also is that what? The side of the rack of teeth is flat. It has flat two surfaces, unlike the spur gear that has the teeth of involute curve. If you look at now, the teeth of the spur gear is in form of what? An involute what? Curve. So let's start doing the rack now. So from every point here, draw a perpendicular downward. So I would like to start from this point, right? So let's start with this point first of all. Or you can decide to start from this point here, the center here. So let's start from C. Now what you do is you take your protractor, right, and you're going to start measuring. How will you do that? We know that the pressure angle is what? 20 degrees. So what I'll do is, this is the center line here. So let me just make it bolder so you'll be able to see that. So we have this way, right? Now I'm going to place, if you look at your protractor, there's always a tiny point here that makes your protractor align with the line you want to measure. So I'll allow this line, this 0 to 0, to align with what? The line AB, such that the center will be on point C here. So now let's do that from point C. But before we are going to do that, right? Before we are going to do that, well, let's just do that and see first of all. So from there, if I align it, I'll discover that the AB line of the AB is on this, is aligned with the 0 degrees on a straight line, and the center point should be on point C here, right? So we'll do that. So this is what we have here, and if you notice it, or you can see it will fall on the same line of 9. Now you see that they are all falling on the same line. So if I measure, I'll measure 20 degrees to the left. So if 90 is here, 90 is 0, this is 10, and this 20. In between each of them is what? 10 degrees. So this is my 10 here, my 20 here. So from this point, now I measure towards the left. So I'm going to draw a line that will pass through point C I used, right? I'll just draw a line this way first of all. So it means that the angle between here and here is what? Is 20 degrees. Are we good? Now, before we continue, we need to draw the addendum and the denudum of what? Of the rack. So the addendum is said to be what? 6 mm. So let's measure 6 mm for the addendum. So addendum is always above the tooth. So from here, I'll measure 6 mm. So I'll come to this point. Let me just draw this here to assist me. So I'll measure 6 mm from this point here. So this is the 6. I'll start from 0. I'll measure 6 upward. So from 0 here, this is 0.5 and this is 6. Then 7.5 is the addendum, the radial depth. So I'll measure 7.5 downward too. So this is 0.5, 6, 0.7, 0.5, somewhere around here. So these are the 2 points. So I'll use my T-square, and I'm going to draw a straight line this way, and I'll come to the addendum too, draw that straight line this way. So now let's move forward. Now I've drawn this from this point. What I did here, I'll do it here too. So I'll come to that point, the second point of the tooth. thickness, and I'm going to draw another straight line too, just like the first one, so it will help me. So from here I'll just draw this. It should be faint line. Now if I do that, I'll take my protractor, I'll repeat the same thing I did. So ensure that the 90 here is on the same straight line as this, you can see that, and the 0 degree should be on the same level with what your AB, your line AB. The 0 degree is there, 0 degree is here, and is what on 92. So if I do that, I'll now measure. Since the first one I went towards the right, then the other point I'll go towards the left. So this is 0, this is 10, and this is 20, and that's my point 20 here. And I'm going to take my rule and join from that point to the point I use for my 90 degree here. So I'll just draw this way. Now you can see that. Now what do you notice? Now this is the addendum, this line of this, the addendum here, right? And this is where it stops. So that I'm going to draw my line from that point, from here, this is where it stops. So I'll just draw it to touch the addendum here. Then I'll come here also, I'll do the same thing here too, to touch the addendum here too. This is a line here, right? So I'll just come. So I'll close it up. You can see that? That is the first one. The reason why I'm not drawing it up to this level, because there's a curve here. Just like what I did earlier, I'm going to do it here too. Now, we know that the wider is giving us 3.43. So it doesn't really even matter. You can at least use any curve, it can be a straight line, it can be a curve. Now I'll do the other one too. I'll come to the next point and I'll repeat the same process. I'm going to draw my vertical line downward this way. See that? So, and I'll place my protractor. Ensure the 0 is aligned with the AB, and this is from a 90. You can see that. So I'll measure. So I'll go towards the right now. So 0, this is 10, and this is what 20. So if I go towards the right here, then I'll not join it from this point. I measure to here. So I'll just come here and I'll draw to touch faint lines first of all. Then I'll do the second one too. From this point also, I'll draw another vertical line downward, faint line. I'll draw it downward on that point. I have this way. So, and I'll place it to be on the line AB. So from there, I've done that, and on the 90, you can see that. So I'll measure, since I measured to the right the other time, I'll measure to the left. So this will be 10, 20. So we have here. So I'll draw it to pass through the point I start measuring from. So we'll be having it this way. This is what we have here. You can see that. So I can easily just close it up. Then I'll bring this down a little bit here. And I'll bring this down to a little bit here. Now the good news here is, and I want to get a curve here using the same 3 points. So I'll place this point, and with the 3.4, I've only 3 that we measured earlier, and getting this curve here, right? You still use that 3, and you place it at, you need a curve here, so you place it at this point here, where they meet at this point. I'll place it and I'll strike an arc. I'll come here also, I'll strike another arc. So where they meet, I'll be able to get my curve this way. So we're having something like that. I'll come here also. So that's for that. Now I want to continue doing what I was doing. So I'll come to this point too. I'll draw a perpendicular line from that point downward, right, this way, and I will ensure that I'll place my protractor on that point on line AB, ensure that it is aligned with the 180, then ensure that the 90 is at this point. You can see that. So what I'm going to do is I always measure this to the right. So this will be 0, 10, 20. So this will be 20 here. I will mark it up to follow that point. So this is the point that we have here. So I'll do this. Now move it to touch here. I'll come here also. I'll do the same thing here. Measure this downward. Measure it downward. Replace it also in the line AB. Ensure the 180 is aligned with the line AB and the 90 is well positioned. So since I marked towards the right at the first time, now I will now do towards the left. So this is 0, 10, 20, 20 degree. So from that point, I'm going to pass it through this point to touch the addendum. So where they are, I'll close it up. You need to close it up. And this, you bring it down. So what you did here, you also apply it here. When you apply it here, you'll be having this. So after you've done that, you can just bring this downward to just go straight, since we've already gotten to where we are. And just bring this downward this way. Then you do the same thing for all this. So by the time you replicate it, you'll be having this. So where's the next point? The next point is this. You also draw a perpendicular line downward from this point. Place it here. And draw it here downward. Take your protractor. You align it. Ensure the line 180 is aligned and the 90 is well positioned. So what will I do? I'm going to mark towards what? Towards the left. This will be 0, 10, 20. This 20. On that 20, I'll pass it through the center. Okay, to touch the what? The addendum. Right. So I'll do the same thing here also. I'll do the 90 downward. Right. Now do the same thing I did, just replicating every move you make. So you're doing that. This is the 90 here. So I'll measure 10, 20 towards the right. So to that point. So in doing that, I'll close it up. And I'll close it up. So the same thing will happen here. The same thing you do it there too. And sometimes it's so small that you can just use a French curve, or you use your hand and you just close it up. You can see that? So you just bring this, taking it from this point to this point. And from this point to this point. Right? So you do that continuously for everything. If I come here too, I'll draw a vertical line and you replicate it for everything. So I'll do this. I'll place my compass, my protractor, ensure that the 180 is aligned with the line AB, and ensure that the 90 is aligned also. So I'll mark towards the left. So this 0, 10, 20. So to pass through this point to the point I'm measuring from. and to touch the addendum. So all these things you are saying will be faint line. Then I'll come here, so I'll do the same thing too. I'll do the vertical line down this way. Here's my protractor. So just measure my. So I place it here. So that it's on 90 and it's there somewhere towards the right. So this is 0, 10, 20 towards the right. And show that it's passing through that point. Right? So there's the point it's passing through. So let's move it. So I'll close it up. You can just use, since it's too small, you can use your hand and just, or your French cuff. You close it up. Then here also you can just, then you close it up. It's up to 5 already. It's a size 5 teeth. So this is 1, 2, 3, 4, 5. So this is where it all ends. This is where it all ends. So depending on your dimensioning, I just take it smaller at any given length. Right? So I can just take it at any given length. So this is the rack and the spur, the pinion guard. So if you found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.